Oh, we already got downvoted? Good. Downvotes are good for your confidence and they build character. So, I'll take them. If you get downvoted, it just builds character. Not Vouch. Lewis who? What's up? What's up? What's up? It's Camille here. Today we're going to do another board repair. Lewis is thankfully back from Florida. From the land of the weird zombies and nothingness. Came back and we're trying to just figure out. This is a coin flip here. I'm kind of not sure if we'll be able to figure this out, but we're going to give it a try. And win or lose, let's hope you learn something. So we have a 1707 here that doesn't turn on, and let's check it out. Ciao de Roma, ciao ragazzi, ciao. Okay, so let's check for any sort of corrosion, and here's my microscope with no light. Oh, that's more better. Okay, that's way more better. Okay. Vouch, yeah, I get vouch all the time. God damn. Not vouch. Buns in here are fine. Don't listen to people. Buns in here are great. They're comfy. So right now what we're checking for is any sort of corrosion on this board, and I'm not seeing any for now. So we're gonna keep looking for corrosion here. And I've been told by someone in my notes that this has very little, if no, corrosion to see or speak of. So let's just double check. Let's scan through the board through our usual spots, all of the shorts and spaces that usually do give us trouble. Lewis' voice change. Yes, it did. Yeah. See, Lewis and Steve came back. They have no tan. There's no tan from Florida. I don't know what they were doing there. Nothing here. Nothing here. ISL 9239 looking okay. Nothing here. So this is a board that doesn't turn on, and we're just trying to slowly figure out what's going on. Oh, okay. Oh, okay. Somebody's been messing with this before, and that's not pretty. Ooh, if we have SOC damage, the T1 chip is under here, so that's probably not fun. Yeah, look at that. Somebody's been messing with this. Okay. Rarely we ever get boards that haven't been messed with before, so no fun. Alright. And we're gonna... Alright, well, let's try to power it on. Let's see what we get. Let's put overhead cam. See, you guys see from overhead, there's nothing here. There's literally... There's some sort of scum over here, but like no visible corrosion anywhere. Like nothing. Thank you, Bruno. So yeah, let's plug this in. Let's, guys, why is everything coded in Flux here? Flux from store.rossmangroup.com. All right. So, all right. So let's get this in focus and in Cadre. What do we got? Kawaii 20. Okay, so something's happening. This is not a turning on voltage. We're getting 20 volts. So the ISL 9239 is working and the CD3215s are working. Let's see what sort of voltages we get here. What exactly is happening? Lots of flux. Yeah, my name's Camille. Hi, everyone. I'm here to do board repair. Hopefully. This is kind of a coin flip here, so if I don't fix it, please don't show up at the store and yell at me. So let's check our PP plus G3 hot, and let's put the multimeter on. Okay. 12.6. Good. Let's check PP3V3 G3 hot, which I forget where it is on this board, but we can easily check with our schematic. So PP3 3G3 hot is also present because we're getting 12.6. So I lied, I know where it is. So just to double check and verify, let's figure this out. This might be a longer one here. Okay, overhead, and our 3V3G3 hot coil is right here. So let's just double check just real quick, right quick. And we're also getting 3V42. Cool, cool, cool. The next thing on this board, if we have both PP-Bus G3 hot and PP3V42, would be the PMIC. Is the PMIC turning on? So let's go to the PMIC and see what's going on over here. Okay. Search A1707, next. Banjo, next. PMIC control, okay. So our PMIC to turn on, it needs to have a VIN, and then it has all of these fun LDOs that turn other things within the PMIC on. So really we need VIN and VIN LDO3 to be present. So let's see if our PMIC is turning on at all. And we will see that through double checking if we're getting this voltage over here. So is my board mirrored? Yeah, it is. Okay. All right. Stop, please. Soldering iron, please. Come on. So this is PP-Bus PMIC, and let's see if that's getting to it. That's 12.6. Okay. And so if we have this VN, we should have some of these LDOs coming out of it. LDO stands for low drop-off, I'm pretty sure. So if you supply a low drop-off regulator with a voltage similar to what it needs to be regulating, for example, if you give it 7 volts, it can make 5 volts out of it. Older regulators, you would need to give a lot higher voltage to drop to. You need to give it, say, like 24 volts to drop it to 12, or 15 to drop it to 5. But LDOs are actually low drop-off, highly efficient. Let's go back to Microscope, and let's just double check our LDOs. So if we actually look here real quick, schematic board view, we're going to go for 3V3 LDO and 5V PMIC LDO, because those voltages will tell us if our PMIC is turning on. Basically, they enable things on the pins in the PMIC. It's like a self-enabling thing. Because if you look at the schematic over here, the 5V PMIC LDO comes out of here, but it comes right back through to power other things right here through R7866, through this guy. So it's kind of like a self-enable mechanism for it. Component to flux ratios off. We're not soldering yet. Okay. Oh, Hi's here. What up, Hi? Greets from Germany. What's up from Germany? Yeah, no cussing on this stream. This is PG-13 when Camille's here. I curse like a sailor outside, though. But all right, so let's measure those LDOs. Let's go for this one first. 3V3 PMIC LDO, and let's go to Microscope. So that's this chunky cap over here, and we're getting 3.3 volts. Cool. And now the second one would be the 5 volt next to it, which is this. And that's not good. Ladies and gentlemen, we might have something here. This should be 5 volts, but it's 0.3. Let's do an owie test. Ooh, there's definitely an owie happening here. Ow. So I suspect that we have an internal short on the PMIC here. So I just hurt my finger, damn. Let's start with removing our PMIC and doing this over here. All right, please bear with me real quick because I'm gonna have to rearrange this desk a little bit. Yeah, I just have to poke my head down there, so we're just gonna put some Q-tips in here. Yeah, it's not my desk, and if I rearrange it too much, I mean, I don't think Lewis will mind. It's just there's a significant lack of boundaries on this desk. Take it however you want. Basically, stuff falls down if you push it. Table space, table space, table space. Put plushies everywhere. Okay. Hi, Piranov. How are you? Piranov is an awesome dude that just shares a lot of knowledge. Everybody say hi to Piranov. I've learned from Piranov's articles a lot when I was learning. Really, really nice dude. We haven't met, but hello. Hello, Polish-speaking friends. I won't be speaking Polish here, however. Everybody knows that Piranov's the man. Alright, excuse this camera angle, but we finally get to soldering. So these pubes over here, that's not out of the ordinary. Okay, cool. So, get ready to fight. Let's go. Where's my flux? Boom, 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 boom. Paul will tell me that it's too much flux. Lewis will say it's not enough. I try to be in the middle. You can get your flux at store.rossmangroup.com. Shameless shill, shameless plug, but it's Lewis's channel, so we're gonna shill and plug as much as we want. Need more flux. I disagree. This is enough. It's floating in flux. 1 Camilla flux, yeah, it's just the right amount. Piranov's probably freaked out that everybody's saying hi to him. Oh yeah, see that? Look like some bridged bowls. PMIC doesn't look too bad, but let's clean those pads up. Can we get the flux capacitor? I mean, that's up to you. Alright, let me go and get my solder. I'll be right back. I forgot to bring my skinny solder. Hold on. Alright, boys and ghouls, we're back. I just saw somebody up front kissing their phone after a screen replacement. So take that as you wish. That was interesting. So why I left because I ran into the same thing. I forgot to bring my own solder. Basically, the solder on Lewis's desk is the top one, and the solder on my desk is the bottom one. So see how this is the thick boy over here, and I have the thin one over here. I prefer this thin solder way more. So I just ran to my desk and grabbed this spool. I'm not fat shaming his solder. Stop. I like the solder to be thick sometimes. It's just in these situations, I don't need it to be thick, you know? With 2 C's, of course. Okay, this one right here might be too small for it. Okay. Boom, boom. Let's heat this up a little. Is Poland winning against Spain tomorrow? Is that the kickball thing, soccer, the Euro or whatever? I don't know. Do we offer international shipping? That's a Daniel question. I also don't know. Hi might be able to tell you if he's still in chat. I know international shipping gets sketchy and difficult, and I think we've done it before, but I don't want to speak out of line. I don't know. All right. So we're just wicking these pads for them to have a better time accepting our new Revolt PMIC. Let's put more flux on this actually, because it's sticking a little bit, so... Okay. Thanks, Hi, yeah. I don't really deal with shipping. I just solder a fixed board. Ooh, missing pad. Let's see if that's a no connect. So we lost the pad. We have a lost soldier right here. And let's double check if we really effed ourselves or not. Hopefully not. It doesn't look like there's anything under it. But just to be safe, we're going to double check. So we lost the pad right here. If you can see this. That's missing, so let's double check. So that's 1, 2, 3, 4, 5, 6 from the right, 3 from the bottom. Schematic board view. 1, 2, 3, 4, 5, 6. 1, 2, 3. That's unconnected. We are good. We're still good, baby. You know what? I should just measure this capacitor over here to see if this is still shorted. Because it looks like it was shorted to ground. Maybe we trolled ourselves and took the PMIC off of it for no reason. Okay, now cool. We have an open loop for both of those. Or 0.3 mega ohms. So it was indeed the PMIC. We did not troll ourselves. Big yay. The PMIC was indeed internally shorted. Okay. Baby. Alright. Let's get rid of this. That's some goop. And this. And now I have a taken off PMIC from Chris that he gave me for this. I don't think it's reballed. Yeah. But let's hope it works. And if not, we're going to grab another one. So this is an iffy PMIC that I have here, a power management unit. And if it works, cool. If it doesn't, we're going to grab another one. So let's try to figure this out. And we're going to use one of these stencils over here. Highly reflective surface. Not good. Very not good. Shit. Okay. Let's see if I can make this work. Lewis, where's your double-sided tape? You don't have double-sided tape, do you? Excuse me for one more minute. I need double-sided tape to secure my PMIC to the board. Yeah. Alright, 1 second, guys. I'll be right back. I need double-sided tape. So, alright. I got my double-sided tape. It's a very invaluable tool for what we're about to do. Basically, the reassembly desks have a whole bunch of tape. I think I can do a brightness adjust on this, right? AE. Okay, cool, better. And so, alright. So, I'm gonna use double-sided tape to secure this chip to my little fixture. Basically, we're using this is really a funky thing. We're using an old iPhone re-sandwiching board, but it's a great heatsink on the other side, so I'm gonna use it to reball our PMIC. So, David, don't look at this. I did steal this from you like 2 years ago. I don't think he even uses these. Boom. So let's just try to peel. Okay, cool. See that? Two sides. Secure your chip on top. Fixture in. Done. Boom, boom. Alright, and back to microscope. Let's get rid of the multimeter. We're not measuring anything for now. Cleanup time. Poor David. David has so many funky tools and gadgets and like bullshit that nobody knows what he needs it for. But it's like, yeah, this is my like specific reballing jig for one chip that only happens on one phone. Yeah, I need it. And you go to like Mobile Centrics and it's like $60 for a piece of custom machine and milled metal that they're like just making a bank on for no reason. But it is what it is if you make it and sell it. See these dead pads over here. Let's see if we can get in there. All right, let's see if I can. Okay, that's a little better. David's son will be fine. David's son needs to do a phone repair video for the Rossman channel. We're waiting for a TriStar replacement that apparently solves everything. Recently he wrote in Slack that some phone wouldn't like do anything, and then he replaced TriStar and everything turned on. And like it was not even the TriStar issue. It was just that TriStar was preventing other things from turning on. So he's just basically saying every phone you have, replace TriStar now. Before you even start the repair. Yeah, the black nail color is protective and metal. So it's a shield from flux and from scratches. Protect yourself, PPE gear. Maybe non-conventional, but let's go. So I just wicked the pads on a chip. Jessa would probably flip because she doesn't wick anything. But we have a few pads over here that I'm kind of like iffy about. They're a little gray, so let's give them a little bit of like a patina scratch. And maybe they'll bond a tiny bit better with our chip. This is also non-standard. You don't have to do this. Just I find that solder sticks better to these if you just work them a tiny little bit. I'm not even pressing on a chip, and I'm not even applying any pressure, but just a little love tap here and there. You don't even have a phone of TriStar? Still, replace TriStar on your Galaxy phone. Do it. Oh, we already got downvoted? Good. Downvotes are good for your confidence and they build character. So, I'll take them. If you get downvoted, it just builds character. We're also going to Vouch. I've seen Vouch like twice on YouTube and that's it. My old roommate used to watch Vouch every day. Just because you have a beard and glasses doesn't mean you have to own people in politics. Oh, I shouldn't probably have done that. That probably blasted your ears. Alright, so there's these like goopy things in here that I want to try to get rid of. Yeah, get out. Upvoted. Thank you. Yeah, I have no opinion on Vouch, but I've been told by my old roommate that I look like him and all my other friends, but whatever. Okay, so now the crucial part. So we have it aligned. Yeah, this is, so for reference, this is our current stencil for the PMIC. This is the Smc Stencil, which is much larger. So this is kind of like the little brother to that. Because this stencil will also rebuild the new SMCs on the 1708 and 17067 series. So it's kind of like a one-fits-all stencil here, so it's very invaluable. I don't know if we have this at the store. I really want to have it because the last time I bought it, I paid $12 or $13 per stencil on eBay, and that's kind of... Dan, get on this. We need this PMIC stencil in the store. So we use this a lot. Alright, so tape one side. Cool. Secured. Tape two side. Okay, and secured. Could probably do this on like a rework station, but this is just the way I've learned, and it's fun for me to do it this way, so let's just do it the old school way. Okay, so that's sitting pretty right here. The thing's sitting pretty. No, it's the PMIC for the 1707. Hopefully that fixes our problem. I had a short on 5 volts LDO on 1707, but knowing life, we're going to replace this, and we're still going to get no turn on. But this is what's in my queue right now, and this is the obvious step to take, so let's try and figure it out. I am very pessimistic for this repair, and we might end up with a no fix here, but every MacBook deserves a second chance, even though they come from our evil overlords. They do deserve to live. Just because you disagree with something doesn't mean it cannot live. Alright, so I'm going to apply my flux now. And so the way I do flux is focus. Focus. Cool. Lewis doesn't do this, but I like to do this. With reballing chips, it's very much like a cowboy jockey style thing. You do it how it works for you, and you don't really care for what's right, as long as you don't overheat the chip, and as long as it works, you should be okay. So this is way too much flux anyway. So what I do is I throw... Yeah, there's no pins, there's only pads. I throw this on a piece of paper towel or paper, and then I squeeze it down and dry this out. Just get the flux. Yeah. Drying out the paste, because when you're using one of these reball fixtures, like one of these tiny heat stable reball chips, they will if you have too much flux under the stencil, what happens is the balls will just pop out of the stencil. So I'm just squeezing it and just getting rid of as much flux as possible in there. And then, see, there will be like oily flux stains here. Yeah, and that's looking a little bit better. Another way of doing this is, I've seen, I think, me or Anel do this, is basically I'm running this over with my chair desk wheel just to apply some pressure to it. And so that will squeeze the flux out. Alright. So let's see. So this is looking more like, kind of like Play-Doh now. Yeah, that's more like it. That's kind of Play-Doh-ish. And so we want to take this putty and apply it directly onto the stencil, like so. And for this one, excuse me, you don't need much. You just need some. But what Chris does, which I found really useful and really fun, is to actually, he's got gloves here, cool, is what you do is you put a glove on, or one finger of your glove, and what you do with this is you push it the hell down. You just push it into the stencil to have even distribution. This is not, I don't know if this is recommended or not, or if this is something that people do, but this is what I do and it works for me. Again, there is no right or wrong way of doing it. So now we have roughly a whole bunch of flux in there, and we're going to switch to microscope and clean that up a little bit. So now that we have this flux in the stencil, the solder paste. I keep calling it flux, it's solder paste, but you can get your flux at store.rossmangroup.com from our Amtech overlords. I do joke about that, but it's really the best flux I've used. Everybody else has that like runny Vaseline thing, and you need that putty thick flux. So yeah, so we're actually removing 1 micropole of flux from the solder paste. Whoever said that is right. Just to have a little drier, less runny solder paste. On bigger chips, on like the SMC itself, I don't do that anymore because I can just get in there and have a properly rebolt chip even with all that flux in the solder paste. The flux in the solder paste is there because when you're using like a rebol, Zaumau type situation, the flux is necessary for the bowls to seal on top of the chip. But, and now wish me luck, we are going to try and get this party started. Alright, let's center this. So we're going to do a quick preheat. And I think this is good. I think we got there. I think this is correct. Okay, I don't see anything that would concern me here, so we're going to go ahead and try to take this off. We're going to reduce temperature on our soldering. What is this? 300, 120? Yeah, on our hot air. And now we gently lift the stencil, and voila! Anything left inside? No, we're good. Alright. Cool, cool, cool. Shiny balls. So now, since the balls themselves were stuck inside of the stencil, we're going to give this a quick reflow, just to... You'll see how they'll like rearrange themselves really quick. So see, they're kind of doing the little dance around, they're rearranging themselves, and this will allow us to properly fit it to the little socket that's there. And so another trick is I go on top of it here with my tweezers, and then I just fold them like so, and then our chip is tape free mostly. Yeah, we can clean that up. Cool. Alright, and so let's get rid of all that goop. Let's get rid of this. And so all adhesives are usually dissolved by some alcohol. So let's see if we can get rid of all that nasty stuff. This doesn't really like hurt it in any way, shape, or form. It's just you're avoiding that weird gelatinous substance on top from being on the chip. So, oh shit. Let's just try and get that off real quick. It's like an extra step, but then your chip just looks nicer and you don't have like burnt gummy stuff on top of it. But then I do have to glue it down to secure it properly, because there is no fixture that these chips fit. and I don't have a CNC plan or any machining, not much machining experience to make one just for this single chip. I don't think it's feasible to do that. So it's easier to just, you know, jig it this way every time. Okay, cool. So the jelly's gone. Way higher airspeed. Honestly, I'm from the Paul school of airspeed, which is max all the time, always. Unless I'm working on things that have plastic around them, and plastic connectors, they usually don't like that much heat. So then we go to that down to 365. At around 365 Celsius, the plastic still does not melt, but solder will melt. See, 3D printing is, unless you 3D print with aluminum, like I think ABS is really temperature unstable, and I think PLA is also not super temperature stable, and I'm hitting this with 500 Celsius, so 3D printing is not really a viable option here. I think I have one of the Creality printers at home, and just you leave something that's 3D printed in the sun, and the thing just like melts. So yep, ABS is out of date, and it kind of sucks. What would y'all use for 3D printing materials if you were to use what is it? Is it FDM printing? Is that the one with extruders? PETG? PETG is kind of rubbery. I don't. We had PETG Plus as filament, and I didn't like the way it printed. Yeah, so I have the Ender and I have the Creality something with the bigger badge that like has all these bending issues. My friend has one of those funky form printers from Formlabs, so I'm thinking of using that, but I don't know if that's temperature stable either. So all right, well, enough yammering about 3D printing. Let's actually put this PMIC back on a board and see if we get any progress whatsoever here. The resin just catches fire? Okay. Yeah, CR10 V3, that's the one I have. What I didn't realize is some things take forever to print. I was trying to print face plugs for speakers, and it's just like 27 hours later, we're halfway done. Yeah, this is 500 Celsius, so like I would have to 3D print aluminum or steel, or which is possible, just expensive. Alright, so let's flux it down. Alright. So, now the crucial point of this, which kind of sucks every time, is the arrangement of this, or alignment. So let's just try to align it proper the first time around so we don't screw ourselves. Because if this slides, I have to reball it again, and not that it isn't fun to do so, it's just I kind of don't want to. Alright. That looks correct. Press E down. Alright. Yeah, it really sucks. You would have to CAD a file and then mill it and machine it out, and then you make a single fixture that may or may not sell and may or may not have the right, tolerances and accuracy. So, road travel channel. This is a road repair channel. That's what it is. Excuse me. Alright, don't slide, don't slide, don't slide, don't slide, please don't slide. Please do not slide, don't slide, and please melt, and I think we got there. Dance, 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 dance. Okay, she danced. So currently what I'm doing, just to recap, we had a short on 5 volts LDO on our power management unit. So this guy right here was internally shorted, and these capacitors over here were showing 0.3 volts instead of 5. So let's just put the multimeter back on. Let's double check if we remove this short. And we're looking at 13 kilo ohms, so the short looks to be removed. And yeah, don't breathe, don't breathe. Okay. Blah, blah, blah. So now we're gonna put it in the cooler system. Oh wow, okay. Alright, well, the board's cooling down, and now we get to find out if our PMIC exchange did anything good whatsoever. Chikami to Polak. I don't know if he's Polish. Yes, Camille's Polish. Everybody just clings on to that for some reason. Rapid cool technology. Okay. Alright, let's see if we cry or not. So, right now we find out whether we cry. I think we're gonna cry. I'm not optimistic here. Goth as hell. Okay, so let's try to figure this out. Alright. Kawaii. 0.2, 0.3, 0.03. Oh, we're crying, man. We're freaking crying. So, let's see if we at least got rid of the short. If that's something that we don't have to deal with anymore. So, if you remember, we had a short on... If you remember, we had a short on 5 volt PMIC LDO. So let's remeasure that. Now no fan spin. So let's just double check if we at least solved our issue before. Chances are this is a bunk PMIC because I found this on my desk and didn't take it off of another board. So that could be it. So 3 volts. Yep. 5 volts. Yep. 12 volts. Yep. Oh, what's this? 1.8 volts. Yep. Alright. What do we have up next? So if the PMIC is working, let's do some schematic digging. If you guys have hints or suggestions, we're gonna go from here and figure out what is the thing that could be messing up next. So this is 1V8 PP1V8 sus on banjo, right? And that's coming out of this guy over here, so we have that. PP1VO sus. Do we have that? Let's double check. 5VS4. I lived in the US for 16 years, so pretty good actually. Well, the power management chip just got replaced, so that's a good it's a good guest transcription. We just replaced that, so we're going to try and figure out where our voltages start to go missing. This might be a lost cause here, but we keep fighting. So this is 1VO. That's 12.6. What is this? PP1VO sus. PP1VO sus is right here next to this guy. Okay, so we have 1VO sus. And what's next? One VO enable RC, that's here, that's here. Let's do 3v3s4, let's check that. How about that? Do we get this at all? Because after sus we have S4, so are we in an S4 state at all? So it's going to be this guy. It's got a nicer, wait, okay, so this guy over here should have, okay, so we don't have 3v3s4. And what enables 3v3s4? So let's just measure this. So we're gonna measure PP3v3s4 on this resistor over here. On this guy over here. We're gonna measure this guy. And we're going to go back to microscope and we're gonna measure him. So that's my PP3v3s4. And that's a 0. We don't have nothing here. And let's double check if PP3v3s4 is not shorted to ground. And we're looking at 3 kilo ohms, which is okay. So we continue hunting. So if 3v3s4 is not there, we're looking, the on pin for this chip is PM Sleep S5L. And if someone gave me a missing PM Sleep S5L on a board repair video, I'm gonna be really sad. I'm not gonna do anything mean, but I'm gonna be really sad about it. Because S5L is even worse than S4L. Okay, so on a schematic board view, we're going to look at this guy over here, or this, and we're gonna go to microscope, and we're gonna measure him. Not open loop, let's check. Let us check the... Oh, I'm really mad. I'm really mad right now. So, some genius gave me missing PM Sleep S5L and said, go ahead, figure this out. But we're not giving up just yet. We're going to check out this circuit right here. Oh, this is also enabled by PM Sleep S5L, right? Because this is 5VS4P good. And 5VS4P good I'm currently using BK Precision Test Bench 390A. That's the multimeter. So this chip gets enabled by 3v3S5. So let's maybe start at, we had sus voltages, so S5 voltages should be here, right? Yeah, I'm getting 3 volts on 3v3S5, so this big cap is 3v3S5 over here. Cool, cool, cool. So that should in turn enable our double buck converter. Yeah, Paul Daniel software, yeah. That sometimes works, sometimes doesn't, but you have to be understanding because it's over COM ports, and COM ports are antiquated. So I'm looking at, let's see, 3v3S5. And what do you get enabled by? You get enabled by this, which is PM enable PVX5S, which is this, which is SMC PM G2 enable. Let's see if we have this SMC G2 enable. Okay. SMC G2 enable. So that's going to be bottom side here. Okay, so the SMC turns on, and we get the enable for S5 rails. So that's good, that makes sense, we get 3v3S5. And so from 3v3S5, we should get P5vS4 enable here. So this right here, the S5 side, we're chilling. And on the other side here, we have the S4 side. So let's see if this PPV enable S5 RCD. So that's PM Sleep S5L again. Let's just double check if it gets to this. But so that's very missing. So let's see where that comes from. Somebody's coming to my door. Yeah, Paul's seeing what I'm seeing. What do you think? PM Sleep S5L missing. Is that revolving good?
Yes.
You think the PM Sleep S5L would be missing from the PMIC?
It's possible, but not probable.
You're giving me hope that's not there. Because no, it comes from PCH right here. So if the PCH is dead, then good night, sweet prince. Because it enables the thing on the SMC as well, right? Because this is a receiving pin.
What LDO was shorted?
5 volts LDO.
Click on it?
On the LDO itself?
On where it was shorted.
Sure. Alright, right here. It's the self-enable for the PMIC. And then, yeah, it just doesn't go anywhere else. It just goes straight back to itself. It's a self-enabling buck. So, I can always swap this if you sleep better at night if I do that.
You had an unknown quality chip. I would try that one.
I mean, I trust my own quality. I found it on my desk. It was in a baggie that said A1707 PMIC. So I don't know.
That was probably good.
Yeah, I'll put yours because that's verified. So we sleep better at night. And otherwise, we have a PCH that is a piece of, yeah. All right, so let's try to replace this PMIC again. And now we have Paul S quality PMIC over here. Came pre-bowled from Paul S himself. Paul only invests in highest quality bowls. He doesn't touch bowls that are not the highest quality. See that? Highest quality bowls. And we're going to put that on. Excuse me, I'm gonna get a drink of my ginger ale over here. Alright. So, PMIC replacement attempt 2. Pole S has the best balls. Yeah, I mean, indubitably. Always clean, always the same size. Hi, Loner Stoner, what's up? Just get a little fluxy poo. Shiny balls. I mean, personally did not see them. The ones I've been provided with are very shiny, at least today for the PMIC. So can attest to that, but only to that. Okay. The furniture, guys. No, I did not. I was not raised in the US, so any pop culture references like that, no. Raised. I wasn't born in the US. Maybe I grew up here, but I wasn't born here. Yeah, like Paul would be referencing, I think, what is the Car Guys or something, and it was like two guys talking about cars or whatever. And I was like, yeah, that sounds great. Never heard of it. Yeah, the missing pad right here, that's a non-connect. We went over this. It's inconsequential. It's unconnected, so it does not have to be grounded. It does not have to be pulled up or pulled down. It's an inconsequential pad. We went over this. Thank you for noticing, though. You're keeping me from here. No, good for noticing. Good on you. What's your name? One Tomek. Alright, don't slide. Oh, I think we're good. I think we got it, guys. I think we got it. We got there. You, sir, come back a little. Come back. Okay. Rapid cooling tech. Tips for steadying your hands while soldering. Have your back straight and don't bend your back too much. If you have a good foundation from your shoulders, it's much easier to immobilize your wrists. Rest your arms on a desk, and if you can, your wrists as well. Have as much stabilization as possible. Basically, stance yourself. When your hands are still shaking, watch your caffeine intake. If you're too caffeinated, your hands will be like this. Low blood sugar also causes your hands shaky. So like eat something. And if you're not working and if you're responsible, and I'm not recommending this, glass of beer. Alcohol steadies your hands like nothing else. Hold your breath. Not really. I don't hold my breath that much. You can, like, the breath thing is more for, like, you know, looking through a magnifying glass or something so it doesn't shake, but it doesn't have that much effect. But half a glass of beer or you know, a bottle of beer will steady the hell out of your hands. But it's too early for beer right now. What is it, 3:30 p.m.? It's not time to party yet, although it is Friday. It's maybe in like an hour and a half. I have a bottle of scotch on my desk for steadying hands, so... Alright, do we cry? We freaking cry. Yeah, like when you're too hunched, I noticed, like basically adjust your desk and your microscope to a point where your back can be semi-straight, and then when you tighten your shoulders and the back, basically bring them together, you have more of a foundation for your arms to be steady. If you slouch over, you get way more shake and jiggle in your arms. There's more stabilizer muscles that are not there. But we're still crying about this board. We're still freaking crying. I'm gonna run real quick to see if our thermal cam does anything to it. I'm gonna check with Anel or Paul or Danny to see if anything gets hot, because we are getting some current draw. So give me 1 minute, and maybe we're not getting PM Sleep S5L because some sort of a short. So give me 1 second. All right, we're back, and we got bad news. Basically, I took it to Paul's desk, and Paul has assessed this board with me, and we checked it out. And so after a long fight with the PMIC and a shorted 5-volt LDO, we have a missing PM Sleep S5L, which is worse than missing PM Sleep S4L. PM Sleep S5L basically comes out of the PCH and turns on the S4 voltages. So let's just do schematic board view real quick. Let's check this out. So in the Intel architecture of chips, we have various sleep states, basically, right? So those states will correspond, to say deep sleep, suspend to RAM, general suspension on, and so these states are called S5, S4, S3. Lewis explained all this. So on this board, we have PP3v3S5. That's present. We have it right here, and it's present, measurable, and good. So that then... Actually, you know what? Let's double check if we have S5 power good. Because if S5 power good is not coming out, we won't get PM Sleep S5L. And if we don't have P good, then we may have some of it hope left here. So let's just see if P good signal... I'm literally just holding to like last straws over here. So when the SMC G2 enable signal enables all of the S5 rails, the chip that makes PP3v3S5 has to give a P good signal to the PCH for it to turn on PM Sleep S5L. So I'm invested in this board, and I would like to double check if we have this P good signal over here, then this board is really dead. And we have this signal. So this S5 P good signal, S5 power good, which is right here if we zoom in on pin 20. Boom, this guy right here. This guy makes its way to the SMC and to the PMIC, and thus gives the signal for PM Sleep S5L to be generated. We can also try the SMC on this, because if power good gets here, let me consult with Paul. Let's try the SMC as well. Maybe we can do this. Hold on. Right, so we're fishing for a board to get for SMC Reball. So I'm watching Paul take this SMC off right here, but he also took the PCH off, so we can maybe tag team this board with Chris later to replace the PCH. So not all hope is lost. Hang on. So we have an SMC hot off the board right now, and we're gonna do a quick reball on that as well. But after that, I'm just gonna give up. After that, I'm gonna give up, and then this will be in a higher power with Chris and the Zalmao. So right now, we're gonna rebuild the SMC for this board and see if anything at all is possible. All right. All right. Second rebuild of the day, hot off the presses. This is an SMC from a 820-00281 board from Paul S. himself. Pre-selected, not pre-bowled, so we have to do the rebuild thing again. Alright. So we do the same thing. We put down some tape. 3M, but you know, we're not sponsored by 3M. 3M, please sponsor us, send us tape. I will review your tape very favorably. It sticks very good. Very sticky. A+. So, alright, let's do it here. And zoometh. Okay, so that probably stuck already. Come on, be nice. So now we're taking the top layer off of this tape. Okay, cool. On goes the SMC. Cool. Yeah. The tape sticks. It does the stick. I have to give me just 1 second. I have a thing I have to answer. I'm back. Alright, cool. I had to do a quick thing, so we had to do a little quick work talk here. Not for stream. Okay. Yeah, I was just trying to figure out a few things about here that we have in our works. The process for what? Stationlist. What would you like me to repeat? So right now we're basically gluing down the PMIC to my little fixture, and we're going to align this stencil on top of it and glue it down. That's not the way it's supposed to be. Freaking hell. Okay. Okay. Alright, this is very precise. Yeah, it's a MacBook on a chip. Okay, so glue that. Okay. I mean, I answered the question like 6 times, so. In the last half an hour, but okay. Yeah, that's exactly what Vince just pasted, so. Okay, so yeah, so we're gonna rebuild this this SMC because we're in never give up, never surrender mode. Boom. There you go. Okay, cool. Yeah, it basically, I think Lewis likes it because the software for it is fairly reactive. Like it can switch modes really quick and it reacts within like 2-3 seconds. So we're gonna stick to that. I still have my old putty solder from the other reball. So we're going to dump a few flecks of solder on top of this. Okay. Come on, stay. Okay, boom. See, it kind of looks like Play-Doh. That's the Play-Doh consistency that you don't want more flux. I think this should be enough, but... Okay, one finger glove wear. Glove. It's freaking bright in here. My eyes hurt from all this light. I don't know, he does it for hours and hours. Okay. So now we grab this and we push it in with our finger. Paul does it with the back of his tweezers. Lois does it with a Q-tip. But your hands are your best tools. Just don't touch solder. So yeah, just use your hands if you can. So I'm pushing this solder in literally because usually for bigger chips, you don't have to. But here you have such small stencil holes that it's really hard to get it equally in all of those little ports. Okay, so now we clean that up a little and get out the excess so it doesn't bubble up on us. And let's see if we can do a pro tip here. Yeah, get out. Yeah, there we go. Cool. All right, so exhaust on, hot air on. It's not dangerous to touch the solder, but you don't want, it's leaded solder, you don't want lead to go into your system. It's minuscule amounts, but it's never too safe. You get what I mean. Okay, cool. If I don't have to, I don't do it. All right, we might be 2 for 2. Are we 2 for 2? No. Okay, so I see a problem right here, and I don't know if you see it but I'm going to point it out. This guy looks to be stuck to the side. He might be okay here. So I'm going to heat him a little bit more. See if we can get that not sticking to the stencil. Yeah, that's a little better. Okay. 5 in, 5 up. I think that was the one, right? That was the one that we were looking at. This looks good to me. Yeah, okay, cool. That looks good. So let's try and take it out. We got tape stuck to tape, not good. Okay. So right now a lot of people would just try to poke this up, and for some chips it's easy, but you don't want to rip these balls out. So, or you don't want to rip any pads. So what I do is I put my hot air on a much lower temperature, like 300 degrees. And I just heat up the flux around it so it comes out. So now we have a clean pull. See that? No solder balls left in the stencil. And we have perfect solder balls on a chip. Cool. Alright, so the next step again, let's give them a little bit more love and heat. So they rearrange themselves like usual. Okay. And they pop into their own natural places now. Or it's still at 300. Let's crank the temperature back up to 5. Okay. And all of our BGA bowls are looking fine. So we do the tape trick again. This really took longer than I wanted it to, but it is what it is. And we're not giving up. We're giving this board a chance. Okay, we got most of the goop off. There's no goop on here. It'd be like that. The corner bowl is missing. It's like a indicator. So this bowl right here is missing, and it do be like that, to answer your question. My temps are in Celsius. Actually, the soldering iron's in Fahrenheit, but the quicks are in Celsius. The old quicks, they only had Celsius mode, and you couldn't switch them, so you just get used to Celsius and Fahrenheit. And let's do this. All right, so our last resort here is basically taking off the SMC and seeing if the P-good signal wakes up the SMC. If this SMC, after replacement, if this board wakes up, we have committed to a miracle. And if not, we're just... What is that saying? Up the creek with no paddle? Or... I don't want to say shit out of luck, but shit out of luck sounds about right. Alright, let's do a quick examination of the BGA array under the SMC. And as far as I'm concerned, as shaky this camera is right now, and please excuse that, we're looking okay. Why does this thing shake so much? No shake. Lewis, please make no shake. Ah, good enough. Alright, so we got a bonus reball in this video. And we're going to wick the pads with some good wick that you can get at store.rossmangroup.com. And we are currently fixing an A1707 820-00281 board, and current status is that we are in denial that the PCH is dead. So let's see where we get from there. Reballing's tough at first, but once it clicks, it's kind of like, you know, riding a bike. You just know what to do. You have, I don't know. I enjoy doing it. I used to loathe doing SMCs, but now it's fine. What's up? No. 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 Did you reball it?
Yes, I did.
You freaking madman. So, while being in denial about the PCH being dead, Paul just went ahead and reballed the damn PCH. But, I'm not putting that with hot air.
I guess you shouldn't.
No, you should not.
You could.
You could, but...
You shouldn't. You could.
Am I going to?
You might.
I'm gonna have to get clearance on this. Because it's one thing if it's for the lulz. Another thing if I break the PCH. So Paul reballed a PCH by hand, and he's a madman. That's a whole PCH reballed. I'm gonna, before I put that on, I'm gonna ask Lewis, because this PCH you should really, you can reball it by hand, but when you're placing it down on the board, you should really have even temperature throughout, and you should heat the board up to at least like 200 degrees Celsius, and then heat the PCH surroundings up to solder melting temperature, because then you are working with a big chip, and then you can you have a lot of board flexing and, you know, internal chip cracking. So I don't know if I'd be comfortable with doing a PCH hand replacement plus on stream. So I'm gonna ask Lewis. Yeah, try Pure Enough's. What is Pure Enough saying? What was Pure Enough's suggestion? If somebody can copy paste that, we can try that before we give up. Check DSW power OK and RSM reset at Camille. We'll do that. Thank you. Keep that in your clipboard. Copy paste it. I'm probably gonna ask for those names again. Okay. Them things sitting. Sitting alright. Alright, so this is the SMC replacement. Let's quickly double check if we placed it down correctly. That looks good. All right. All right, cool the board down. All right, so according to Piernov, we should check different signals, and they are called DSW power OK. So let's check what that is. PM DSW power OK or power good. Okay. Thank you for 10 polskich złotych. Dobry wieczór. Dziękuję bardzo. Okay, so this power good comes from what? What do you do, dear sir? You are the enable for from the PCH to the PMIC, right? Is that what I think it is? Yeah, DSW power OK. Yeah, like there's a hint here to just give the PCH some heat, a little bit of love, just to see if it turns back on. If then it turns on, then it's worth exchanging it. But we're going to try and turn this back on and see if we cry or not. So we have an SMC replacement and a PMIC replacement that happened here, and we are going to see if we're crying. Oh, nice. 1.4. It was the SMC, I think. Oh shit. No. Did it die? Something gets hot. I think we're good. I think we hit it. I think this is it. I need a test screen. I'm gonna go to Paul. Excuse me for 1 second. Evil laugh. Lewis is saying no way. All right, let's see if we have image, because we might be celebrating too early. If we don't have image, we're still SOL. So if I get Apple logo here, I deserve the weekend off. Right? Okay. All right. So the moment of truth that we've all been waiting for, unless I have a huge freaking short on the board, this should turn on. Please? Pretty please? Come on. Make the Apple thing. Put logo. I think we're crying still. Oh, nice. Oh, this doesn't get old. Nice. All right. Let's go over what was fixed and what didn't get fixed. So the initial problem that we had, just to recap, we had a short on PP 5 volt PMIC LDO. This is a self-generating, self-enabled voltage line. Basically, wow, blanked out over there for a second. What happens is when the PMIC gets the VIN pin on NSIC, gets PBOS PMIC, it turns on all of its LDO, which are low drop-off regulators at 5 volt. PP5V PMIC LDO was, as I checked earlier, I don't think I checked on the screen, it was 3 ohms to ground. We had 0.3 volts on PP5V PMIC LDO, and we replaced the PMIC. And we replaced that voltage from 0.3 volts back to 5 volts. But then we went from that to having no PM sleep S5L voltage. So we basically checked PP333 S5 enable. And the PP333 S5 enable also goes to here and here. And what am I looking for? This. The signal that the S5 lines are enabled with is called SMC PM G2 enable. So we had that signal, so we had that signal and that enabled our S5 lanes. When the S5 lanes are enabled, we go back to this chip and we have an S5 power good signal, right? So that the chip's saying, hey, I got the S5 lane, it's power good, it's powering on, and that signal then goes from R7802 and it joins the PMIC, which we knew was good, and the SMC. So the next thing I wanted to do is just replace the SMC and see if the S5 power good would correctly wake up the S4 or the sus lanes. So from then on, I figured, you know what, let's switch the SMC and see what happens, because my PM Sleep S5L was basically missing. The S5 power good signal, I think, wakes up PM Sleep S5L. And so when the SMC receives S5 power good, it should generate PM Sleep S5L or PP5VS4P good, which in turn, right here on this resistor, becomes PP3V3S5. So yeah, long story short, PM Sleep S5L was missing. It comes from the SMC. The SMC was getting an S5 power good signal, and we figured, hey, if you're getting the power good signal, you should generate PM Sleep S5L, and it didn't. So from then on, we replaced the SMC, and we got Apple logo. So this was longer video than I hoped. It was 2 rebolds instead of 1. We rebuilt the PMIC and the SMC. We exchanged both, and from there on, we got an Apple logo and a login screen, unfortunately. So I think that's it for me today, and we got another good 1707 repair coming up, I think, and I hope you learned something. Take it easy.